This is chapter 9.3, Connecting Graphs and Rational Functions. Rational equations can be solved graphically or algebraically. You must check for extraneous roots when solving algebraically, just like we did in chapter 2 with our radical functions. Solutions, roots, and x-intercepts are all the same value. So if it says find the solutions, or if it says to solve, or if it says find the roots, or find the x-intercepts, or if it said to find the zeros, those all mean the same thing. Solving rational equations algebraically. It's a 5-step process. First step is to factor the denominators and find the lowest common denominator. Step number 2, list any restrictions on the variable, so find our NPVs. Step 3, multiply each term by the lowest common denominator to eliminate all fractions. Step 4, solve for the variable. And step 5, check our solutions both with the NPVs to make sure they're not one of the NPVs, and also by subbing into our original equation and making sure that the left side is equal to the right side. Let's give this a try. Solve each equation algebraically. Find the roots, solutions, zeros, determine the x-intercepts. So any of those statements would mean do the same thing, solve it algebraically. I'm going to split this up here. First one, 14 divided by x minus x plus 5 equals to 0. So step 1, factor the denominators to find the lowest common denominator. Our only denominator here is x, which can't be factored. So moving on. Step 2, list any restrictions on the variable. We have x as a denominator, so that means our NPV would be x equals to 0. Or we could say for our restrictions, x cannot equal to 0. Step 3, multiply each term by the lowest common denominator to eliminate all fractions. So whatever our lowest common denominator is, in this case, we only have one denominator, so that's going to be our lowest common denominator. It's going to be x. We want to multiply both sides by x, our lowest common denominator. Okay, so multiply everything in the equation by x. If we multiply 14 over x by x, the x's divide out to 1, so we're left with 14. Multiply x times negative x, we get negative x squared. Multiply x to 5, we get plus 5x, and then equals to x times 0 is still 0. Step 4 is to solve for the variable. I want to write this in standard form, but I want my x squared term to be positive, and right now it's negative. So I'm going to move these 3 terms to the other side of the equal sign. So if I have 0 equals, I'm adding x squared to both sides. I get positive x squared. Subtracting 5x from both sides, negative 5x, and subtracting 14 from both sides, negative 14. We have 0 equals x squared minus 5x minus 14. Now we want to solve for our variable by factoring or using the quadratic formula. I'm going to factor this one. 2 numbers that multiply to negative 14 and add to negative 5. We'd have to have one positive and one negative since they multiply to a negative, and they add to negative 5. So negative 7 and positive 2 would add to negative 5 and multiply to negative 14, which means our x values that satisfy each factor being equal to 0 would be x equals to 7 and x equals to negative 2. Next, we want to check our solutions. We want to check them with the NPV. So our NPV was 0, which is not one of our solutions, so that's okay. But we also want to check them by subbing them back in. Take x equals 7 and plug it in. 14 divided by 7 minus 7 plus 5 equals 0. 14 divided by 7 is 2. Negative 7 plus 5 is negative 2. equals to 0, 0 equals to 0. So that is true, which means x equals to 7 is definitely a solution. X equals to -2. 14 divided by -2 minus -2 plus 5 equals to 0. 14 divided by -2 is -7. And then we have plus 2 plus 5, so plus 7 equals to 0. 0 equals to 0. So that is true as well. So our solutions are x equals to 7 and x equals to -2. -2 divided by x plus 3 equals 2 plus 5 over x. Step 1, factor the denominators to find the lowest common denominator. We can't factor our denominators, so moving on. Step 2, list any restrictions on the variable. We have x plus 3 on the bottom of a fraction, which means one of our NPVs is x equals -3. We also have x on the bottom of a fraction, so we also have an NPV of x equals to 0, or we could say x cannot equal -3 and x cannot equal to 0. Step 3, multiply each term by the lowest common denominator to eliminate all fractions. Our lowest common denominator is our two denominators together, so x times x plus 3. Let's multiply that to each of the terms. If I multiply x times x plus 3 to the first term, the x plus 3 on top and the x plus 3 on bottom will divide out. So we're left with -2x equals 2 times x plus 3. And then 5 divided by x times x plus 3. The x on top and the x on bottom would divide out to 1. So we'd have 5 times x plus 3. We've gotten rid of our fractions. The next step is to solve for the variable. Let's multiply the coefficients into the brackets. -2x equals 2x squared plus 6x plus 5x plus 15. Next, we want to combine like terms. -2x equals 2x squared plus 11x plus 15. Let's move this -2x over so everything's on one side. 0 equals 2x squared. We'd have to add 2x to both sides. So plus 13x plus 15. Let's factor this. We don't have a common factor. 2, 13, and 15 don't have a common factor. It's a complex trinomial, so we need to multiply the a term and the c term. 2 times 15 equals 30. We want two numbers that multiply to give us 30 and add to give us 13. They're both positive numbers since they add to a positive and multiply to a positive. So we would have 10 and 3, 10 and 3. Next, we need to use either the box method or decomposition to factor. I'm going to use the box method. If you're not familiar with the box method, 2x squared goes in the top left. Our constant term 15 goes in the bottom right. The numbers we just determined, 10 and 3, followed by x because they represent 13x, go in the other two boxes. Doesn't matter the order. And then we look at what's the common factor for each row and column. So starting with my top row, 2x squared and 10x, common factor would be 2x. Bottom row, 3x and 15, common factor is 3. First column, 2x squared and 3x would just be x, and then second column, 10x and 15 would be 5. This means that our binomial factors are 2x plus 3 and x plus 5. That's our factored form. Then we want to get our solutions. From each of our factors, 2x plus 3 equals to 0. If we subtract 3 from both sides, we get negative 3 equals to 2x. Divide by 2, we get negative 3 over 2, or x equals negative 1.5. And then for x plus 5 equals to 0, subtract 5 from both sides, we get x equals negative 5. Last step is to check our solutions. So looking at our NPVs, x equals to negative 3 and x equals to 0 are the NPVs. Neither of our solutions are those values, so that's okay. Next, we need to check our solutions by subbing them in and making sure the left side equals the right side. I'm going to zoom in here. Need as much space as I can get. X equals negative 1.5. We want to sub that in to our original, which was negative 2 over x plus 3. Negative 2 over negative 1.5 plus 3 equals 2 plus 5 over x plus 5 over negative 1.5. Let's calculate. Negative 2 divided by bracket negative 1.5 plus 3, close bracket, gives us negative 1.33. Change that to a fraction. Math, enter, enter. Negative 4 over 3. And then 2 plus 5 divided by negative 1.5 gives us the same thing. Math, enter, enter. Negative 4 over 3. So that one works out. And then checking x equals to negative 5. Negative 2 over negative 5 plus 3 equals 2 plus 5 divided by negative 5. Negative 5 plus 3 is negative 2, so we should have negative 2 divided by negative 2, which should be 1. Let's make sure. Negative 5 plus 3 is 1. And then 2 plus 5 divided by negative 5 is negative 1. 2 plus negative 1 is 1. 1 equals to 1. Yes. So that means that x equals to negative 1.5 and x equals to negative 5 are solutions. Last one, x over x minus 2 plus 2 over x plus 3 equals 10 over x squared plus x minus 6. Step 1, factor the denominators to find the lowest common denominator. We can factor our trinomial, x squared plus x minus 6, two numbers that multiply to negative 6 and add to 1 would be negative 2 and positive 3. Get rid of that now. Next step, list any restrictions on the variable. We have x minus 2 on the bottom of our fractions, so an NPV would be x equals to 2. 2 minus 2 would give us 0. And we also have x plus 3 on the bottom of our fractions, so x equals negative 3 is an NPV. Step 3, multiply each term by the lowest common denominator to eliminate all fractions. Our lowest common denominator would be x minus 2 times x plus 3. Multiply everything by x minus 2 times x plus 3. Our lowest common denominator. When we multiply x over x minus 2 by x minus 2 x plus 3, the x minus 2's divide to 1, so we're left with x times x plus 3. When we multiply 2 over x plus 3 by x minus 2 times x plus 3, we're left with 2x minus 2 because the x plus 3's divide to 1. And when we multiply 10 over x minus 2 x plus 3 by x minus 2 x plus 3, we are left with 10 because x minus 2's divide to 1 and x plus 3's divide to 1. Next step is to solve for the variable. We need to start by multiplying our coefficients into the brackets. X times x is x squared. X times 3 is 3x. Plus 2 times x is 2x. 2 times negative 2 is negative 4 equals to 10. Move everything to one side and simplify. We have x squared plus 5x minus 4 minus 10, so minus 14 equals to 0. Now we can factor this. Two numbers that multiply to negative 14 and add to positive 5 would be 7 and negative 2, which gives us x equals negative 7 and x equals positive 2. Then we need to compare our solutions to the NPVs. So our NPVs were x equals 2 and x equals negative 3. Well, one of our solutions is x equals 2, which is an NPV. So that cannot be a solution because it's an NPV. So our only possible solution is x equals to negative 7, but we still need to check that by subbing it in and making sure the left side is equal to the right side. We'll do that. Negative 7 over negative 7 minus 2 plus 2 over negative 7 plus 3 equals 10 over negative 7 squared plus negative 7 minus 6. Let's calculate. Negative 7 divided by bracket negative 7 minus 2 close bracket plus 2 divided by bracket negative 7 plus 3 close bracket, enter math, enter, enter, we get 5 over 18. Onto the right side, 10 divided by, I need a couple sets of brackets here, one for the bottom of the fraction, one for the negative 7 close bracket squared, then plus bracket negative 7 close bracket, then minus 6, then close the bracket on the denominator, enter math, enter, enter, we get 5 over 18. So yes, the left side equals the right side, which means x equals to negative 7 is our solution. Next example, solve the equation 2 minus 3x over 2 equals to 1 plus 4x minus x squared over 4x plus 10 graphically. Express your answer to the nearest hundredth. Verify your solution algebraically. Let's bring up our graphing calculator. Again, we can move everything to one side and graph one function, or we can graph the two sides of the function as separate graphs. I'm going to do that. 2 minus 3x divided by 2 is my y1. My y2 is bracket for the numerator, 1 plus 4x minus x squared, close bracket for the numerator, divide bracket 4x plus 10, close the bracket for the denominator, enter, and then graph. So my window is set to standard, plus 10, minus 10 in both directions. So here's what I see. It looks like I have a vertical asymptote at x equals about negative 2.5. I can kind of trace along my rational graph to see, and it is approaching x equals to 2.5 as we go that way, and also as we go this way. So we'll draw a vertical asymptote at negative 2.5. Since we graphed two functions, our solutions would be the x values of the intersection points. I'm going to start by sketching my linear function, which is the left-hand side. Y equals 2 minus 3 over 2x. So our y-intercept is 2, and our slope is negative 3 over 2. So down 3, right 2, down 3, right 2, or up 3, left 2. Y-intercept at 2, down 3, right 2, down 3, right 2, down 3, right 2, and then up 3, left 2, up 3, left 2, and I can join those points with a line. Next, I can use my graphing calculator to draw some points for my rational function to graph that. I'm going to find my x-intercepts, number 2 for 0. I need to be left bound, so I'm going to do this first x-intercept, which is about there. So left bound of that would be down here, hit enter. Right bound of that point would be there, hit enter. And then it is at negative 0.2 and 0. So almost at 0, 0, just to the right of 0, 0. I'm going to do the same for my second x-intercept. So I can trace number 2. My x-intercept is here, so I want to go left bound, enter, right bound, enter, and it's 4.233. So 4, just past a 4 there. That part of our graph looks something like this. Then we can find our intersection points. So I can trace number 5. Let's find the intersection point that's down here first. So first curve, enter, second curve, enter, guess, enter. Okay, and it's doing this again. So I'm going to use my Casio calculator. And my Casio calculator tells me that the intersection point down here, this one, is at x equals to 1.14 rounded to the hundredths place, and y is 0.29. And the next point is negative 3.34, and y value is 7.01. So about here. Going back to our graph. So this side looks something like this. And this intersection point was negative 3.34 and 7.01. Our solutions are the x values of the intersection points. X equals to negative 3.34 and x equals to 1.14. And then we need to verify our solution algebraically. Starting with x equals negative 3.34, plug it into our original function and make sure the left side is equal to the right side. We have 2 minus 3 times negative 3.34 divided by 2 equals 1 plus 4 times negative 3.34 minus negative 3.34 squared. Divided by 4 times negative 3.34 plus 10. 2 minus 3 times negative 3.34 divided by 2 gives us 7.01. Let's check if the left side equals that. Bracket the numerator, 1 plus 4 times negative 3.34 minus negative, bracket, negative 3.34, close bracket, squared. Close the bracket for the numerator. divide, open bracket for the denominator, 4 times negative 3.34 plus 10, close bracket for the denominator, and we get 6.9986 ... which again, these solutions, x equals 3.34, that was rounded, so we would expect to get the two sides might not be exactly equal, but they're very close, so we say that that's verified. Next one is x equals 1.14. Sub it in, 2 minus 3 times 1.14 divided by 2 equals 1 plus 4 times 1.14 minus 1.14 squared divided by 4 times 1.14 plus 10. Calculate 2 minus 3 times 1.14 divided by 2 gives us 0.29. And the right side, 1 plus 4 times 1.14 minus 1.14 squared. I need brackets around all of that, so I'm going to go backwards. Open bracket and then close bracket after. Divide, open bracket for my denominator, 4 times 1.14 plus 10. Close the bracket for my denominator, enter, we get 0.2926 ... So yes, that verifies our solution. And we can say that x equals negative 3.34 and x equals 1.14 are solutions to this rational function. Solve the equation 2 minus 3x over 2. This is totally the same as the last page. Okay. It is supposed to be, if you happen to have your notes that have this equation in it for some reason, that's just because I copied and pasted and then didn't change the equation. It should be x plus 3 over 2x minus 6 equals 2x minus x over 3 minus x. That's what it should be. So solve that algebraically and graphically. Compare the solutions found using each method. I'm going to do algebraically first. Step number 1 is to factor the denominators where possible. X plus 3 over, we can factor out a 2, 2x minus 3 equals 2x. Now, looking on the bottom of this next fraction, I have 3 minus x, but it would really be helpful if I had x minus 3 so that we had the same binomial factor in the two fractions. So if I factor out a negative, then I can switch the 2 and write it as x minus 3. We get negative x over negative x minus 3. We have two negatives with this fraction. We're subtracting the fraction, and then we have a negative on the bottom, which means we can just get rid of this negative on the bottom and change this to plus, because we had subtracting a negative, which turns into adding. Next step, we want to list any restrictions on the variable. We have x minus 3 on the bottom of our fractions, so our NPV would be x equals 3. Next step is to multiply everything by the lowest common denominator, which in this case would be 2 times x minus 3. If we multiply the first fraction by 2 times x minus 3, the 2x minus 3 on top divides to 1 with the 2x minus 3 on bottom, so we're just left with x plus 3. 2x times 2 times x minus 3 gives us 4x times x minus 3. And x over x minus 3 times 2x minus 3. The x minus 3's divide to 1. We're left with plus 2x. We want to simplify, combine like terms, and solve for x. Multiply the 4x into the brackets. X plus 3 equals 4x squared minus 12x plus 2x. Move everything to one side. I'm going to subtract x and subtract 3. I get 0 equals 4x squared. We have minus 12x plus 2, which is minus 10x. We're also subtracting the x from the left. So minus 11x. And then we are subtracting 3 from the left, so we have minus 3 as our constant term. Now we can factor this. It does not have any common factors for 11 and 3, no common factors. So it's a complex trinomial. Multiply 4 times negative 3, which is negative 12. We need factors of 12, factors of negative 12 that add to negative 11. One's a positive, one's a negative, since they multiply to a negative, and the negative one is bigger. If we did negative 12, positive 1, negative 12, positive 1, that would multiply to negative 12 and add to negative 11. Next, we're going to use the box method. First box, 4x squared. Bottom right box, negative 3. Other two boxes are negative 12x and 1x, doesn't matter what order. Common factor, the top row, 4x squared and negative 12x is 4x. The bottom row, x and negative 3 is just 1. The first column, 4x squared and x, is just x. And the second column, negative 12x and negative 3 is negative 3. Just a reminder, when using the box method, if you have a negative at the beginning of your row, which would be on the left-hand side, so at 4x squared or x, that's the beginning of the rows. If those are negative, your common factor is negative. For the columns, if the top of the column is negative, then your common factor will be negative. So whether there's 1 negative or 2, if the negative's in that position, your common factor will be negative. So in this case, we just have negative 3. So it factors to the binomials 4x plus 1 and x minus 3. That equals to 0. Let's solve for our x values. 4x plus 1 equals to 0. 4x equals negative 1. And then x equals negative 1 over 4. And here we have x equals to 3. So those are our two possible solutions. Let's check. So first, comparing to our NPV. Our NPV is x equals to 3. We did that up here. But our solution, we said one of them was x equals to 3. So that cannot be a solution. Now we just need to check our other solution, x equals to negative 1 over 4. We'll plug it in to the function and see if the left side is equal to the right side. Negative 1 over 4 is negative 0.25 plus 3. 2 times negative 0.25 minus 6 equals 2 times negative 0.25 minus negative 0.25 over 3 minus negative 0.25. Let's calculate. Left side, I'm going to bracket for the top, negative 0.25 plus 3, close bracket, divide, bracket for the bottom, 2 times negative 0.25 minus 6, close bracket. That gives me negative 0.423 blah 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 and the right side 2 times negative 0.25 minus negative bracket negative 0.25 close bracket divided by bracket 3 minus negative 0.25 close bracket, and we get negative 4.23 blah blah blah. So yes, that is a solution. So our solution is x equals to negative 1 over 4. Next, let's do it graphically. Go to our y equals, clear what's in there. Again, you can enter the left side as one function and the right side as another, or you can move it all to one side and enter it all together. If you did that, you'd be finding the x-intercepts. But if we graph it in two functions, we're going to find the x values of the intersection points, which is what I'm going to do. Bracket x plus 3, close bracket, divided by bracket 2x minus 6, close bracket, enter. Next one, 2x minus x divided by bracket 3 minus x, close bracket. Graph, and here's what I get in standard view. As we would expect, we have an NPV of 3, so our vertical asymptote is at x equals to 3. Let's find the x-intercepts for the red graph first. Second trace number 2, left bound here, enter, right bound there, enter. 0, 0 is one of them. Second trace number 2, left bound, enter, right bound, enter, 2.50. Those are our x-intercepts for the red graph. So that portion looks something like this. And then let's do the blue graph, the x-intercept, second trace number 2, left bound there, enter, right bound there, enter, and it's at negative 3, 0. And then we want to find the intersection points, second trace number 5, enter, enter, yes, no. Oh, look, it's actually going to tell me this time. So we have negative 0.25 for the x, and then negative 0.4 something. So we'll say, I'll do it in black, we'll say that it's about here, negative 0.25 and negative 0.42. So this part of the graph looks something like this. And then we have a part up here as well. Looks something like this. Okay, so we get our solution from our graph is x equals negative 0.25, which is the same as we got when we did it algebraically. Last example, you are organizing a fundraiser for the local children's hospital. You are asking local businesses to each donate a door prize. You have asked 9 businesses, but only 1 has donated a prize. Your goal was to have 3/4 of the businesses donate. If you succeed in getting every business to donate a prize from now on, how many more businesses do you need to ask to reach your goal? Let's look at the information that we have. So we've asked 9 businesses. Only 1 has donated a prize. Our goal is 3/4 of businesses donate. And from now on, every business is going to donate, every business that we ask. So we want to know how many businesses we need to ask. Our function, we'll call it f of x, would be the ratio of number of donations over number of businesses asked. Let's let x equal the number of businesses needed to ask, because that's what we're trying to find out, is how many more businesses do we need to ask if every business says yes. So our goal is 3/4, and that's going to equal the number of donations, which currently is 1, plus the number of businesses we ask from now on, because everybody is going to be donating from now on according to our question. And then over the number of businesses we've asked, which currently is 9, we've already asked 9, plus we're going to ask x more. There's our function. Now we need to solve our function. So step 1, factor denominators. They're already factored. Step 2, list restrictions on the variable. We have 9 plus x on the bottom of the fraction. So NPV would be x equals to -9. Then we want to multiply everything by the lowest common denominator, which would be 4, 9 plus x. If we multiply that first fraction by 4 times 9 plus x, the 4's divide to 1, so we get 3 times 9 plus x. If we multiply the second fraction by 4 times 9 plus x, the 9 plus x divide to 1, so we're left with 4 times 1 plus x. Multiply the 3 into the brackets, multiply the 4 into the brackets, we get 27 plus 3x equals 4 plus 4x. Move our x's to one side, so I'm going to subtract 3x, and move our constants to one side, so subtract 4. We get 23 equals x. So according to this, we need to ask 23 more businesses. Let's check this answer. It's good with our NPV, because our NPV is -9. So let's plug it in to our function and see if the left side is equal to the right side. 3/4 equals 1 plus 23 over 9 plus 23. 3/4 equals 24 over 23 plus 9 is 32. We can divide 24 by 8, we get 3. We can divide 32 by 8, we get 4. So that gives us 3/4 equals 3/4. So true, which means that we need to ask 23 more businesses. X equals to 23 is our answer. Let's draw a quick sketch of this. Clear that, clear that. We have 3/4, 3 divide 4 as one function, and then bracket 1 plus x, close bracket, divide bracket 9 plus x, close bracket, enter graph. And here we go. So our window on this little graph we're given is very different from what I have. So it is 0 in the negative x direction. It goes up to 25-ish in the positive x direction. And then it is 0 in the negative y, and only goes up to 3 in the positive y. There we go. There's a better sketch here. 3/4. About there. And then graph our rational function. We know that they are going to intersect at x equals to 23, so it will look something like this. That brings us to the end of the Chapter 9 lessons.